Section 6.2, use proportions. Our goal today is to use proportions to solve geometry problems. When we're talking about proportions, as we have in the last two sections, we find that there are different ways you can write a proportion and still solve it correctly. Today we're going to directly talk about those. So number one, when we're talking about equivalent proportions, is we're going to start with A over B equals C over D. You notice I have the means here, B and C are in blue, and what are called the extremes are A and D. In other textbooks, instead of calling it cross multiply or geometric mean, they call it the means extremes theorem. We're not going to be doing that. But so our first property, if two ratios are equal, so A over B equals C over D, option number one, then their reciprocals are also equal. So this is option number two. So we flip both fractions. Notice we still are multiplying B and C together and A and D together. So we really haven't changed what we're multiplying, we're changing what it looks like. Option number two. Oh, I'm sorry, that was option number. The next way, you can also change the means of the proportion to get another true. Notice here we flip-flop the blue ones. You notice C and D are now switched. That is our third equivalent proportion. So we can, notice we're still multiplying the reds and the blues together, so still another equivalent proportion. And the last one is probably the weirdest or most difficult, is that another true proportion can be formed by adding the value of the denominator to its numerator. So in this case, we add B to A and we add D to C. This is option number 4. So when it says to write 4 equivalent proportions, you're looking at writing 1, 2, 3, 4, as we have them numbered here. Those are the 4 equivalent proportions we are talking about. So in this diagram, AB over DE is equal to AC over DF, right? 4 true proportions. Number 1 is just a matter of plugging in the numbers. So if we look at the diagram, AB is 12 over DE, so 12 over 9 equals AC, 8 over DF, X. That's number 1. Number 2 is the reciprocals. So 9 over 12 equals X over H. Number 3 was to switch the means, B and C. So we're going to have 12 over 8 equals 9 over X. So we just switched our means on that one. And then number 4, the weird one. So we're going to have 12 plus 9 over 9 equals 8 plus X over X. And I'm fine with you leaving it as 12 plus 9. To me, that shows you know where the values are coming from more than having 21 there as well, especially with how many math there. Some of you it may be easier if you just leave it as that appears. And that's it. That's all you need to do for writing for true proportion. Problems like this, it says in the diagram you have a proportion. Solve for HI or KI. Well, looking at KI is here in the proportion, so we are going to solve that one first. So HK is H. KI unknown, we'll call it X. HJ is 12, and JG is 20H. And now we are going to cross multiply and solve for X. And then I'm going to divide both sides by 12 and get 58 over 3, which is approximately 18.6. Repeating. Is that a nice answer? Not really. But not everything is going to work out to be a whole number. So this is 18.6 repeating, or if you're around to the nearest hundredth, this would be 18.67. Okay, there's Ki, it also said to find Hi, so we know that this was 18.67. Now to find Hi, it is simply the whole length, so Hi is going to be 8 plus 18.67, which would be 26.67. Alright, scale. It's a ratio that describes the dimensions of the map, the model, the drawing to the actual dimensions. So scale is, like we say here, a ratio, and when solving with scale, we will use a proportion. So it says here the scale of the city map is 2 inches equals 1440 feet. Find the length of a street that is 3 inches on the map. So we will start with 2 inches over 1440 feet. That is our scale. So 2 inches over 1440 equals, and we're given 3 inches over unknown, let's try y this time, y feet. Again, it's just a matter of write a proportion, plug in, you know the scale. In this case, you know the scale, 2 inches equals 1,440 feet. You know the length on the map, and now it's just a matter of cross multiplying. And then we divide by 2 to get y equals 2,160 feet. That's the length of the street on the map, 2,160 feet. Alright, there are going to be times you can find the scale, or find the relationship between the actual and the model. So here it says you have a 3D model of the Sears Tower, now called the Willis Tower, recently renamed, still known as Sears Tower in the South. The actual building is 1,203 feet tall, and your model is 29.4 inches tall. How many times as tall as your model is the actual building? So what we're going to do is, we're going to do actual over model. We're trying to find what is the relationship or what is the ratio. So we have 1,703 feet over 29.4 inches. And here brings up a problem. We cannot compare feet to inches. In order to have a ratio, you need the same unit. So what we are going to do is we are going to convert feet into inches. So we're going to multiply by 12 inches over 1 foot. And then, so we're going to convert this, and we're going to have that we have 2,436 inches over 29.4 inches. So we converted from feet to inches. These cancel, and now it's just a matter of dividing 20,436 by 29.4. And when we do that, we get that it is equal to 695.1. So we will use the word about. 695 times taller. Again, the biggest thing with these problems, you have to have the same units. You need to convert from feet to inches, inches to feet, yards to miles, whatever the conversion may be. You need to have the same unit before you start dividing.